This video is on using the high-low method to create a formula that helps us predict future costs. In the past video, we looked at cost behavior. Variable costs are very easy to predict because they're linear, and for one more unit, you have one more set of costs. Fixed costs are easy to predict because they don't change with volume, but mixed costs are more difficult to predict. In order to predict mixed costs, we want to break it into a fixed and variable component. We're going to start by using the high-low method, which is a very easy method to do on the back of an envelope while you're sitting at a restaurant discussing a business idea and you don't have a computer readily available. Let's look at some data. You can see on the screen we have our first set of data, and the first step in doing the high-low method is to see if you have a reasonable cost driver. So what we're looking at here is we have 10 weeks worth of data. We have put our predicted driver, what we think is our cost driver, into column B and the quantity of that. Now remember, a cost driver might be direct labor hours, it might be machine hours, it might be the number of units that we're producing, it might be the number of parts that go into something. Whatever it is, that is what we believe is driving the cost. And then in column C, we have the actual costs that we've accumulated themselves. So this may be the cost that we spent producing whatever our widget is. And we want to know, for example, is it true that if we use 206 of our drivers, that our cost will always be around $2,267? We want to be able to predict that. So the first step is to do a scatter plot. And what we're going to do is come over here. We want to select the data, including all the cost drivers and all the costs. Don't include the observation numbers, just the cost drivers and the costs, and don't include the titles either. Come up here to your insert and chart and choose the scatter. See, this is the scatter plot. Just choose the first scatter plot. And now we can look at this chart. Does that look like there's a good linear relationship there? Is there a line we can draw through this that most of the points are close to? I don't think there is. There doesn't seem to be any relationship here at all. So what this tells us is that we've chosen a poor cost driver. This is not the cost driver that's going to help us predict our costs. Let's look at another set of data. We still have 10 observations. We have our cost drivers and we have our costs. And so let's do that scatter plot again. We want to come through and select the data, including all the cost drivers and all of the costs, but nothing else. Choose Insert, come down here to Charts, go to the Scatter graph, insert Scatter or Bubble Chart, and just choose the first simple one. This looks a lot better. That looks like there is a linear relationship. So we're going to look at this and try to solve the equation. So what we're trying to do is we're trying to come up with an equation that says y is our cost that we're trying to predict. It is also the dollar amount that we see on the y-axis, the up and down or the rise in the chart. Y equals the variable cost, and remember the variable cost is the slope of the line, times x. X is our cost drivers. We want to see how many cost drivers, be able to predict it based on cost drivers. This is called our independent variable, or our x-axis, or the run, plus f, and that's our fixed cost. So there's the equation that we're trying to come up with, y equals vx plus f. The first step in this is to calculate the variable cost. The formula is rise over run. Now what we need to do is we need to use the high and low values of the cost driver, not the dollars. So if we come over here and we look, we have our low cost driver 22,730. That is our low. So let's go ahead and highlight this and call this our low. Highlight that with yellow. Notice that this has got a lower dollar amount. There is a $680 amount, but we don't want that. We want to go from the lowest driver to the highest driver. Ignore the low and the high dollars. Just look at the low and the high driver for right now. So our high driver is up here. It is the point that is at 70 and 1450. So we're going to find that. Here it is, 70 and 1450. Those are the points that we're going to use. And then the formula is rise over run. And when we talk about rise over run, we're talking about the change in dollars, or the change in the y-axis, over the change in activity, or the change in cost driver, the change in the x-axis. And so in this particular case, we're going to have 1450 minus 730 over 70 minus 22. Let's see what that looks like. So when I put that down, I get 1450 minus 730. That's the change in the rise, or the change in the dollars, divided by 70 minus 22. That's the change in the cost driver. That equals 720 divided by 48, which is $15. That $15 is our variable cost. So now we've determined that the variable cost equals 15. We need to go in and calculate the fixed cost. So to calculate the fixed cost, we want to use the same points we used before, the 70 and the 22, so the high and the low week. We want to plug it into the y equals vx plus f framework and solve for f. So let's see what that looks like. We're going to start out by taking the first point, 1450 equals 15, that's our variable cost, times 70, that's our driver unit from that high, plus f. And when we solve for f, we get 400. To double check it, let's put it into the second equation. So 730 were the dollar amounts from our low observation, equals 15 is the variable cost that we predicted, times 22, which is the driver, cost driver from our low observation, plus f. We solve for f, we get 400 again. That means that our formula is y equals 15x plus 400. We've solved this equation. We've figured out that y equals 15x plus 400. Now what we want to do is a point estimate. Let me type that out. We want to do a point estimate. Point estimate is when we want to predict our cost for a specific activity point. In this case, let's look and see what happens when we have 45 drivers. Okay, we're going to have 400, that's our fixed cost. We're going to have a variable cost of 15 times 45. This is when we have 45 drivers. So our total cost then is going to be 1,075. So our point estimate when we have 45 drivers or driver units is 1,075. And we can go ahead and format that and highlight that. That's our point estimate. So we just plugged 45 into the equation. Now, is this a good estimate? Is it a robust estimate? Do we think that this is going to work really well? Well, that's a good question. One of the problems with the high-low method is how much it can change if we just change a few little things. So let's take a look at this example one more time and make a couple of changes to it. Okay, so we're back to the beginning. Everything is cleared off. This is exactly what we started with. We've identified our high and our low, but notice that those are in weeks 9 and 10. What would happen if they had decided to do this analysis at the end of the 8th week? Let's just go ahead and delete these two observations. You can see that the chart updated. It no longer has those two observations. We have a new high and low. Again, remember, we're going to pick up the high and the low based on the cost driver, not on the dollars. Our low is over here. It's 26 and 820. Even though we have a lower dollar amount, we're not going to use that. We want to pick up the high and the low based on the cost driver. And then our high is 56 and 1090, so we're going to pick that one up, 56 and 1090, even though we have a higher dollar amount. Does a line still work through here? Is this still a linear equation? Yes, it still looks pretty good, right? Our observations are still kind of going from the lower left to the higher upper right corner of the graph, so we can still probably use the high-low method. Let's go ahead and work through the math on this high-low method and see what we end up with. So we're going to start out by saying we want the change in the rise, right? Change in rise. So we want the 1090 minus the 820. That is our change in y, or our change in rise. And we're going to divide that by the change in the cost driver, or the change in x, or the change in the run. Okay, so 270 divided by 30. So 270 divided by 30 gives us 9. Let us just make sure that there's no pennies or anything on that. That's an even 9, okay? We'll go back to the dollar format. Now we're going to plug that into our equation and solve for our fixed cost. So remember that our formula is y equals variable times x plus our fixed cost. When I put those into the formula, I pick up from the first variable $1,090 equals $9. That's our variable cost, times 56, which is our cost driver, plus f, and I solve for f, I get 586. Do it again just to verify these have to be the same number or I've done something wrong. 820 was our cost in our low observation, equals 9, the variable cost, times 26, that's the number of cost drivers in the low observation, plus our fixed cost, solve for f, and I get 586 again. I can now write this equation, right? My equation is y, that's the cost we're trying to predict, equals 9x plus 586. Is that the same formula that we got before? It's not, is it? Before we had y equals 15x plus 400. So these are not the same thing. What happened? Well, we got rid of a couple of observations and our lines moved. Let's look at that other chart real fast. Right, so this is the other chart next to it. You can see that the two charts are the same, but once you take out the low observation and the high observation, your line is going to be a little bit different. So one of the problems with using the high-low method is that the results are not necessarily robust, or they don't necessarily hold up over time. There may be outliers, and if your outlier is a high or a low, it can sway that line. You may have more data, doesn't necessarily give you a better fit than less data, because you're only looking at 2 points on the line to determine the slope of that line. You're not taking every point into consideration. So high-low is a great method to come up with a formula to predict your total costs when you have a mixed cost and you have limited time or no computer access. This gives us a point prediction. Let's compare our point predictions. Do you remember what our old point prediction was? With all of our data, remember that we said when we have 45 drivers, then 1,075 is the estimated cost. Well, let's see what happens when we have 45 drivers under the new method. What we have now is y equals 9x plus 586, and when we plug 45 in as x and we solve, we get 991. So the same data in the middle, but we got rid of those outside observations and it changed our line significantly. How do we fix that? We go to regression analysis, and that's the topic of the next video.